Today, we're going to talk about percent. We're going to take that next step. It's still a form of a ratio and rate, actually, but not really a rate because we don't have units. But what we're comparing two numbers. In this case, and one thing I really love about percent is they actually tell you in the name exactly what it is. Okay? But we'll get to that in just a second. Let's talk about a few other things first. First off, in percent, a lot of times we'll be using formulas. Formulas are an equation that shows a relationship between certain numbers or certain quantities. You're going to see a lot of formulas in math, especially as we continue on, get towards the end of the year. We're going to do surface area, volume. All of these different things have formulas. The nice thing about formulas is you guys have the advantage of people a lot smarter than me or Ms. McShann sat down and realized there are certain relationships between different things, and they put it into a formula for you. The good thing about formula, literally all I have to do is substitute in a value, and it gives me the answer. Formulas are magical. One of the most famous formulas is a guy named Einstein, probably one of the smartest men to ever live. He came up with a formula to figure out how much energy something has. The formula is E equals mc squared. Okay? So if you know the mass of something, we now know the speed of light. We've measured it pretty well. You can actually figure out how much energy something has. But formula is just one of those things, one of those tools you will be having in math. Understand, when we say formula, it's just an equation, meaning there's an equal sign, something on both sides, that shows that relationship. Most of the time in an equation, we are going to use a variable. We've talked about variables. We've talked about defining a variable, but just make sure you have the definition. A variable is a symbol, usually a letter, used to represent a number. What are the most common variables that we use in mathematics? Nope, actually isn't, believe it or not. X and Y. So our most common variables are X and Y. We're going to get back to that in just a second. Percent. Again, here's why I love percent. The definition is in the name. What does per mean? Out of or divide. What is cent? Anybody know what Latin for cent is? I'll give you a hint. How many cents are in a dollar?
100.
So when I say percent, what do I mean? Out of 100. Per 100. The symbol for percent looks like this. And many of you may not have known it, but that hint is also in your symbol, because the percent symbol is just a 100. The 1 is between the zeros, 100. Okay? So you should remember what percent is. I'll give you a hint. Understanding the definition of percent is going to help you immensely in everything that we are going to do with percents. Understanding that it means that it is out of 100. Now, honestly, we should have done this next part a lot sooner, and next year, depending on our new curriculum, we probably will. It's how we write multiplication. Now, Ms. McShann's already done a great job. She's put together these posters for you guys and put them on the walls to help you see how to write these in case you get confused. Because historically, you guys have always learned to write multiplication like this, correct? You put an x between them, 2 times 4. But what did we just say? Now it looks like a variable. And so we can't use x anymore because it looks like a variable. Literally, when Ms. McShann and I are looking at your paper, we don't know if you mean 2 times some quantity x times 4, or if you're just saying 2 times 4. It makes a big difference. Okay? So in order to avoid confusion, we're going to move to the more advanced way for writing multiplication, which is using a raised dot in between the two numbers. Really important word there, a raised dot. Make sure it's not so low that it looks like a decimal. Okay? It is the up in between the numbers. That is, this right now is our preferred way for you to write multiplication. Because we are going to be doing equations, because we are going to be using variables, a lot of times you're going to see a number written right beside a variable. That is saying multiply the two. Here's the issue. Now we're going to start having you substitute values. In other words, we're going to tell you what R is. So a lot of times when I rewrite that equation with the new variable, we're going to actually use the parentheses. Because what this is doing, two major times you'll see this. One is if I'm now substituting a value, so I know that I'm multiplying it. The second is if we're doing order of operations, and I've got some series of numbers in the parentheses. Once they reduce to one number, if there's a number directly outside of it, that's telling you you're going to multiply it by whatever that quantity inside was. Okay? But the bottom line is we need you guys to get rid of this in your mathematic notations. Please don't be using the X anymore. I'll give you a hint. We will start writing notes on your tests and quizzes. We're not going to take points off for it yet. But by the end of the year, if you're still continuing to put that X in there, you will start losing points on that. Any questions? Okay. The other big piece we're going to be doing today. Yes, I know I forgot to put the standards on our opening slide today. I've been asked that more times than I ever thought I would. But we are doing a lot of other things today as well. Yes, Wesley? Yes, I would still use it. If I'm actually showing my multiplication, I would still use the X there. Good question. Okay, the big thing we're going to do today is switching between percent, fraction, and decimals. The nice thing is they're relatively easy to do. You just need to understand the process, but it all comes back to percent is out of 100. As long as you can get that drilled into your brains, everything we're going to do makes sense. So our first one is going a percent to a fraction. So let's take a number like 85%. You guys should write this into your notes. So you'll have an example right beside this, okay? Now, what am I going to do? To turn 85% into a fraction, the first thing I'm going to do is write the number portion of the percent. In other words, I write down the 85. I'm going to then place a fraction bar with a 100 below it. Why do I put 100 below it? Because percent is out of 100. It is the definition. Okay? And then we simplify using our 4 key numbers. How many of you have gotten your 4 key numbers down? 3 of you? That's not so good. Okay, what are the 4 key numbers?
2, 3, 5, and 7.
Good. So if you still don't have that, please write it into your notes again. Because this is what makes simplifying easy. Literally, all I'm going to do is I'm going to take my fraction. I'm going to check both numbers. Can I divide 85 and 100 evenly by 2? No. Can I do them evenly by 3? By 5? Yes. So I just go through that checklist until I say yes, and then I do it. So I divide those both by 5. That's going to give me 17 over 20. Then I check again. Can I divide them both by 2? By 3? No. By 5? By 7? No. If I say no 4 times, guys, it's in simplest form. That is the beauty of the 4 key numbers. It tells you once you're in simplest form. When you say no 4 times, you're done. There are a couple exceptions, but that's where your second factor comes in. So if I said yes to 2 and yes to 3, I need to check my second factor, but that's very rare. Okay, this next one, percent to decimal. This is where we look to the God of all sodas, Dr. Pepper. He is your best friend. Okay? Dr. Pepper shows you what to do. There's 3 things on this. The D stands for decimal. The P stands for percent. The 2 tells me how many places I am moving it. The arrow actually shows you which way you're moving it. So the arrow goes alphabetical. D goes to P. That's our start. On the top, if I've got a percent, then I'm going to decimal, I'm going to the left. So what I need everybody to do, everybody have a pencil in your hand?
Yes.
Hold it up like you're writing. Okay? Like you're writing, Nora. You write like that? Really? Okay, there we go. Okay, everybody. What I want you to do is I'm going to take my pencil and I'm going to make 2 loops to the left. Go 1, 2. You just changed a decimal or a percent to a decimal. Probably because I should have mirrored it properly. So let's try that again because we need some work on that. I'll mirror this time instead of moving to the left. So all of you, move to your left. Go 1, 2. You just changed a decimal or a percent to a decimal. Hard work, right? Now, watch when we go percent to decimal to percent. It is just as hard. Everybody hold your pencil up. Now you're going to go to your right. 1, 2. You just changed a decimal to a percent. What do I mean by this? Let's put some numbers up to show you. Guys, please quiet. So our first one, I'm going to start with a decimal, go to percent. So let's start with, say, 78%. If I do not see a decimal place, where is my decimal?
Right behind the number.
After the last number, meaning it's behind that 8. So to change it to a decimal, percent to decimal, you see I'm going to the left twice. 1, 2, and I can rewrite that as 7/800ths. I dropped the percent sign. Make sense? What if I'm going a decimal to a percent? So if I start at 5400ths and I want to make this into a percent, I go right. How many times? 2. So then I add the percent sign because I've now changed it to a percent. Now, where does this get tricky? Once we start losing a couple numbers. So, for example, one of my decimal is 6/10. That's not ours. Okay, what is our trick? We move it how many times? Twice. So I move it twice. 1, 2. What do empty buckets get? A 0. So I put it in. 6/10 equals 60%. Okay? What about if I have a decimal as part of my percent? What if it was 34.8%? Does that change anything? No. I still start where my decimal is. Where's my decimal? Right here. So I move it twice. 1, 2. That now becomes 348 thousandths. Make sense? Any questions? Okay, our last one is actually where this whole percent being out of 100 makes the biggest difference. Turning a fraction to a decimal. No, it isn't. Let me change that back. That was actually the fraction to percent. Fraction to decimal is the one you guys should already be familiar with. Because a fraction is just what? A division problem. So if I have a fraction, such as 3/4, in order to change this to a decimal, all I'm going to do is do the actual division. Now, I'll be honest with you guys. One thing that I always struggle with is remembering when I'm going to do the division, which number goes where. So I came up with a little something that hopefully will help some of you, if not all of you. If I look at this 3/4, which one of those guys would you consider a winner? 3, right? Because he's on top. That's the way it looks to me. So the way I think of this is the winner gets to go in the house. The loser is left out in the ring. Okay? So once I've done that, now I can start to do my division. Will 4 go into 3? No. So technically, I put a 0 above that. Bring in my decimal. Remember to bring your decimal straight up. And I can add a 0. So now I say, will 4 go into 30? Yes. How many times? 7. Gives me a 2. Still not at 0, so I'll add another 0 and bring it down. How many times will 4 go into 20? 5. Subtract 20. Now I'm at 0, so I'm done. So 3/4 equals 7/500. Now, quick side note. If that winner in the house doesn't help you out, here's another thing to think about. If you have done the math and I have a fraction, am I going to get an answer bigger than 1 or less than 1? Less than 1. So if I do the division and I get an answer bigger than 1, what does that tell you? You put the numbers in the wrong spot. So redo it, switch your numbers around, put that winner inside the house, then you'll be okay.
Well, you can't honestly divide 3 by 4.
Yeah, you can. We just did.
No, it says divide by 3 divided by 4.
Yeah, you can. We just did.
It says 4 divided by 3.
No, that's 3 divided by 4. Okay. So that's that. Let's go ahead and open up in your modules. Turn back to page 98. You're on page 101, so you're going back to page 98. Okay, our first one. Let's work this one together. Suppose on a Saturday morning you can cut 3 lawns in 5 hours. Your friend can cut 5 lawns in 8 hours. Go ahead. The question is, who's cutting at a faster rate? So we've already taught you this. They gave you the setup on this one, so it should make it easy. All we're missing is our magic box. How do I go from 5 to 1? Divide by 5. So what am I going to do to the 3? Divide by 5. So I take 3, divide by 5. It won't go into the 3, so I put a 0, bring up my decimal, add a 0, 5 goes into 30, 6 times. Subtract 30, I'm down to 0. So how many can you do? 6/10 of a lawn in 1 hour. Okay? Our next one. All we're missing is a magic box. How do I go from 8 to 1? Divide by 8. So what am I doing to the 5? Dividing it by 8. 5 divided by 8. It won't go into 5, so I bring up my decimal, add a 0. That's going to go 6 times. Subtract 48. Gives me 2. Still not at 0, so I'll add another 0. 8 goes into 20 twice. Subtract 16 gives me a 4. Still not at 0, so I'll bring in another one. 8 goes into 40 5 times. Now I finally made it to 0, so my answer is 625 thousandths of a lawn. So have we answered the question yet? We did? Emma? Good. What is the sentence? Who is faster? Who's faster? So my friend cuts lawns faster. Which makes me sad because I'm used to winning. Guys, do you understand that setup? Now, here's another key. I haven't looked at all the homework in here yet today, but having already corrected 2 classes worth of homework, I will let you know one of my biggest heartburns is you guys, for some reason, feel that writing this piece out is too much work, and all of you want to go straight into doing the math. That was my thought, JJ, but you would be shocked if you looked at the amount of homework I've looked at today where students did not do it. So please, guys, we're teaching you this process for a reason. Please utilize it, especially on the ones like this where you're ending up getting into decimals, and you're actually going to see another one. For those of you viewing from home, we get a special treat today. Ms. McShan is actually going to get up and get on video for us.
Oh my God.
I know. Okay? So we're going to pause now. You guys don't have this written in your modules, but here is the story that goes with number 2.
Okay.
So, figure all this out, do the math, and Ms. McShan will be up shortly to walk through it with you.
All right, guys, let's go over this one. Suppose you own a restaurant. You want to do advertising, so you hire 2 students to deliver menus around town. Darla delivers 350 menus in 2 hours. and Drew delivers 510 menus in 3 hours. You promise a $10 bonus to the fastest worker. Who gets the bonus? So we have to use the information they gave us for each person to figure out their rates. So let's start with Darla. What do we know about Darla's delivery skills? Anybody? Just tell me. $350 menus in 2 hours, and we are going from 2 hours to 1 hour because they already gave that to us. So what do I do to 2 to get to 1? So that means I have to do the same thing to 350. So how many times will 2 go into 3? That leaves 1. Bring down my 5. How many times will 2 go into 15? That's 14. It leaves 1. Bring down my 0. 2 into 10? And that leaves a 0 remainder. So she can do 175 menus in 1 hour. Now we need to talk about Drew. What do we know about his delivery skills? So I'm going from 3 hours to 1 hour. How do I get there? So I need to divide 510 by 3. 3 goes into 5 how many times? That leaves 2. Bring down my 1. How many times? That's 21. Leave 0. I still have to use the 0 they gave me. Can 3 go into 0? No, it goes 0 times. So I get 170 menus per hour for Drew. So looking at this, who got the $10 bonus? Darla, because she delivers 5 more menus per hour. You have to have your sentence for a word problem. Word problems need word answers. Any questions? All right, the next one is on the top of the next page, so turn your page. The problem will be up here, and you work it out on your paper. All right, guys, yours was already set up, so I'm going to go ahead and set up my fractions. All right, so yours should look like this, yes? Okay, so which runs faster, a cheetah that can run 60 feet in 4 seconds, or a gazelle that can run 100 feet in 8 seconds? So let's start with the cheetah. What do we know about his running? He runs 60 feet in 4 seconds. So if we're going from 4 seconds to 1 second, we're going to divide by 4. So I need to divide 60 by 4. How many times will 4 go into 6? Please wait until I ask the question before you answer. Bring down my 0. How many times will 4 go into 20? 5. And I get a 0 remainder, so I know the cheetah can run 15 feet in 1 second. Now we're talking about the gazelle. What do we know about the gazelle? 100 feet in 8 seconds. So now we're going from 8 seconds to 1 second. What do I do? Divide by 8. So 8 into 100. Can 8 go into 1? Can it go into 10? So that's 10 minus 8, and that leaves 2. Bring down my 0. 8 into 20? 2. That's 16. 20 minus 16 is 4. I don't have a 0 remainder, so I have to add a decimal to my answer and bring down a 0. 8 into 40? And that's even 40, so I get a 0 remainder. So the gazelle can run 12.5 feet or 12.5 feet per second. So who runs at a faster rate? The cheetah runs faster. Five, 4. Guys, when I take a breath, it is not code word for you to start having a conversation. All right, the next problem, you have the fractions, but they did not label it for you, and they did not give you any numbers. So it is up to you to label it and put the numbers where they go and solve this problem. Yes? Please do your best. There are 2 questions for this problem. You need to answer both of them. All right, guys, I'm seeing some confused faces, so let's talk about it. The secretary in the main office can type 225 words in 3 minutes, while the computer teacher can type 105 words in 90 seconds. Can we still compare them with different units? Can we compare them with one saying minutes and one saying seconds? Have we ever done them with them having different units? No. So we're going to have to convert one of them to either minutes or seconds. So we're going to convert the 90 seconds into minutes. So how many minutes is 90 seconds? Wesley? It is 1.5 minutes, or 1.5 minutes. So that is what you will use to solve your problem, not the 90 seconds. All right, so you have until lunch to work this out. I'm going to give you a couple more minutes, and then as soon as you get back, we'll go over it. All right, guys, let's go over this one. It was not set up for you. You had to set it up. So you should have had words over minutes. And it's, you know, if we're talking about rate, you're trying to find one of something, so 1 minute. All right, so let's start with the secretary. What do we know about the secretary's typing speed? Sean?
The typing speed is 3 minutes, and the number of words is 225 words.
3 minutes. All right, so we're going from 3 minutes to 1 minute. What do we do? We're going to divide by 3, so I have to divide 225 by 3. Can 3 go into 2? No. Can it go into 22? How many times? That's 21. Leaves 1. Bring down my 5. 3 into 15? How many?
5.
That's 15 and leaves a 0 remainder. So the secretary can type 75 words in 1 minute. The computer teacher, we know she can type 105 words in 1.5 minutes. So what do we do to 1.5 to get to 1? Divide by itself. I divide by 1.5. So I have to divide 105 by 1.5. Can I divide by a decimal? No. What do I have to do? I have to move the decimal behind the number to make it a whole number. If I move that decimal once, what else do I need to do? She says I need to make it 10 times more for the other number, which in reality is right. We have to move the other decimal 1 time to the right. Where is a decimal on a whole number? At the end. So I move it once, add a 0, and I get 1,050. So can 15 go into 1? No. Can it go into 10? Can it go into 105? How many times? 7, and that is 105 even. So I bring down my 0. Can it go into 0? No. So I put a 0. And the computer teacher gets 70 words per minute that she can type. So who types at a faster rate? The secretary types at a faster rate. Make sure your word problems have word answers. Any questions? All right, Mr. Moore is going to come go over the first page of homework with you.
So your first page is 100. Honestly, guys, of the 2 pages, this is the one that's a little more complex.
Right.
So pay attention on this one. I'm going to give you a couple hints that the other classes didn't get, so please pay attention. All of these are comparing rates. I will tell you now, having checked 3 classes of homework, it is very frustrating that we have tried to show you how to be easily successful and you guys think it's too much work, so none of you want to do it. You just want to jump straight into your answer. Please don't. There is a reason for all of the madness that we teach you. Please give us some faith. I would hope after a whole quarter we have earned your trust and we've earned your faith, that we don't just make you do work for work. There's a reason for what we ask you to do. This is the type of problem that shows why we've asked you to do this. Okay? I'll give you an example. On the first one, it wants who walks at a faster rate. They give us 2 rates, 60 and 10, 42 and 6. Set up each one as an individual rate. 60 feet, 10 seconds, equals feet, seconds. My magic box. What do I want to do to compare? I want to have how many seconds? 1. So literally all I do is go 10 to 1. How do I do that? Divide by 10. That gives me 6. Is that too much work?
No, it's easy.
So please do it. Do it for both sets. So 42 feet, 6 seconds, equals feet, seconds. How many seconds do I want? 1. How do I go 6 to 1? Divide by 6. That's 7. Is there anything in here that I'm asking you to do that's too hard?
No.
So please do it. Show your work. Show your work for all 6 problems. Now that I've done this, do I know who's faster? Who? The second person is faster. So there's not a ton of room on this page, but you should be able to get your work shown. There's not that much to do. And make sure you answer the question. Now, couple key notes. Number 4, this is the most difficult page on the problem. Why? It gets into decimals. What?
Because the most difficult page on the problem.
Oh, sorry. The most difficult problem on the page. Man, she had to be right because more than her laughed. She does get candy from me. The other little twist they throw is on number 5, minutes and hours. So, easy conversion, 30 minutes is half of an hour, or 70 miles is 60 minutes. Personally, I would probably go to the half hour. Makes it easier. Okay? None of the rest of these are difficult. Turn the page. Okay, at this point, we need everybody to have 3 colors. You can have pens, crayons, colored pencils, highlighters, markers. We don't care. Just make sure you have 3 different colors. We'll give you guys 2 seconds to get that. On this one, Rob's fruit farm consists of 100 acres on which 3 different types of apples grow. Yes, sir?
So I haven't done page 70. I will do it at home and I will turn it into on Tuesday.
Sounds good. 25 acres. He has Empire, Macintosh go on 30%. The remainder are Fuji. Shade in the grid below to represent the portion of farm for each apple. So there's our first part. Use a different color for each type, another piece of instruction, and create a key to identify which color represents each type of apple. Okay? So 3 things we need to do. That's why you needed to go grab 3 colors. So I'm just going to use yellow for my first one. So our first one, we have 100 acres. It says 25 acres have the Empire apples. So how many blocks am I going to color in? 25. So that's 2 whole rows plus 5 out of the 3rd row. That would give me 25. Now I do realize you guys aren't as good at drawing as I am, so I know it'll probably take you a little longer. That's okay, I'll excuse you. And don't forget your color key. Whatever color you use for those Empire apples, just put it right beside it. That's your color key. Okay? So now let's talk about the math part of this, our part to whole ratio. So how many parts did we just color in? 25. What was our whole? How many are in this whole block? 100. So that one would be 25 to 100. Can I simplify that? By 25. If you saw 5, that's great. It'll just take you an extra step. If you saw 25, you realize it's 1 to 4. Okay? Our second one, it said it's 30%. So again, getting back, what does percent mean? Out of 100. So if it's 30% and I have 100 blocks, how many am I going to color? Make sense? Good. So our next color, we're going to now use a different color. We're going to color in 30. Now, we're using 5 out of this row, so that means I need 2 additional whole rows plus 5 in the next row. Okay? So that gives us 30. 5, 20, and 5 equals up to 30. So pretty.
What? Is it so pretty? The new character that has to be pretty.
It doesn't. Oops, I forgot to do my key. Ooh, that was dangerous. Okay, don't forget your key. Don't pull Miss McShann on that one. Okay, now, what's our part to whole ratio for the second one? 30 to 100. What can I divide both those by? 10 gives me 3 to 10. Can I go any further than that? No. And then our last one on the Fuji, that says it's whatever is left, correct? So how much do I have left? 45. So I color in the rest of them with my third color. Yep, basically the rest. Because it said there's only 3. We've already done 2 of them. The remainder means whatever is left. So I gave us, don't forget your color key again. No, it was Miss McShann. How do you forget? We just said it. Oh, that's right. Sean's abandoned me.
Yes. You know that Sean's on her side, right? She's really
I know. Oh, thank you, Madison. Miss McShann. Oh, I wish you guys could have seen Miss McShann's face right there. I'm talking about the people that at home might be listening to the video. So our last one, how many did we count? 45. We're still looking out of 100. What can I divide both those by? 5. So we divide by 5, and that gets us 9 to 20. Can I go any lower than that?
Yes.
Nope. Run through my 4 numbers. Can I divide them both by 2? By 3? By 5? By 7? If you said no 4 times, you can't go any lower. Not 4. 4 doesn't go into 9 evenly. Cosmos, get all these written. Okay, our next problem. The shaded portion of the grid below represents the portion of granola bar remaining. What percent does each block of granola represent? In other words, what does this block represent? What percent? 1%. How did you get that? Good. So he just said, well, Mr. Moore, you and Mr. McShann just taught us how easy it is to switch to decimal from percent. So if I move that twice, I get a 1. That's how easy it is to go decimal percent, guys. Or you could have said, well, there's 1 block out of 100. 1 over 100 is 1%. Because percent means out of 100. If I have 1 out of 100, that's 1%. Next question, what percent of the granola bar remains? Mateo? Wait, you're saying 20%. Is it 80 or is it 20?
This is what percent of the growing up is 20.
Wesley, why do you say it's 20? Okay, so the shaded part is 20. Hold on, guys. Let Wesley explain, please. Okay, but what did it tell you the shaded part represented? So what's your answer now? 80%, guys. Why? Because, and I'll admit that is kind of backwards. For some reason, just the way my mind works, when I look at this initially, I would have said what remains. I would have just focused on saying what remains, and I'd have automatically gone to that. But it's the importance of paying attention to directions, which hopefully you guys learned on day one with us when we gave you that whole sheet of paper. I can already tell Madison still remembers that one. She really did have a classic response on that one. Okay, guys, quiet down. We still got quite a bit to do. What other ways can we represent this percent? So we gave you 3 ways at the start of class today, right? Mateo? 4/5. How did you get that? So we turned it into a fraction. How do I do that? I write the percent, I put it over 100, and I simplify. I can divide both those by 20. That gives me 4/5. What else could I do? 8 what? So what would that be? Turn it into a decimal. Remember, if I don't see my decimal place, it's at the end. I move it twice, and so that becomes 8/10. So there's 2 easy ways to do that, right? Any questions? I could do what? You're right. I could divide 80 by 100. That would also do it. So if you want to do it from the fraction form, but quite frankly, guys, percent to decimal is the easiest thing we're going to ask you to do this year. All you got to do is remember which direction to move it. Okay, turn the page, please. Quiet down in the back corner. Micah? Yeah, I know it was all of you. That's why I said the back corner the first time, but then the second time you were the one I caught still talking. Now, what they've done, they've given us a series of pictures and saying each figure represent the gray shaded region as a percent of the whole figure. Write your answer as a decimal, fraction, and percent. So we need to do it in all 3 formats. So the way I'm going to do it, because these are block 100s, percent is super easy because all we got to do is count it and then put it over 100. So I'm going to do that first. Then percent to decimal is the easiest one to do because literally all I'm doing is moving my decimal twice. Then I'll finish off with fraction. Okay? So percent equals P, fraction equals F, and decimal equals D. So for picture A, the first picture, the dark gray shaded, how much is it? 20. So the percent would be 20%. Turn that to a decimal. What do I do? Move it 2/10. Turn it into a fraction. Very simple. I write the number 20 over 100. Why? Because percent's out of 100. What can I divide 20 and 100 by? 20. So if you see 10, it'll take you 2 steps, but that's fine. If you do it by 20, it's 1/5. Is that hard?
No, sir.
Okay, so let's try another one. What about picture B? What do you think, Sadie? The darkest gray. How many blocks is that? 25. Well done. So that makes it 25%. How do I turn that to a decimal? Literally, just move it twice. 25/100. I have to underline my answers. Don't ring the bell. Turn it into a fraction. I write the number 25, put it over 100. What can I divide both those by? Sean, suddenly I'm glad you've decided to stick with Miss McShan. Yeah, he said divide 25 by 100. It'll go evenly. I don't think so. Okay, then our last one. Now this one's going to take you a second, unless somebody already did it. Did you do it, Serial? 48. That sounds about right. So I'm going to take your word on that. If anyone else wants to double check him, just to be sure. He's good? Okay. So 48%, how do I turn that to a decimal? Serial? Move it 2 times to the left. So that becomes 48 hundredths. Turn it into a fraction. Write the number, put it over 100. What can I divide both those by? 2. So I divide them both by 2. That gives me 24 over 50. Check again. Can I divide both those by something?
10.
Miss McShan, he is definitely yours. Divide them by 2 gets me 12 over 25. Check again. Can I divide both those by 2? By 3? By 5? By 7? If I say no 4 times, I'm in simplest form. That's it. Okay, see how that 2, 3, 5, 7, your 4 key numbers works? Makes it a very easy check for you. Any questions on anything we just did on those? Pretty easy? Okay, so we are probably going to come back and do some more of these problems, but unfortunately we're almost out of time. So turn to page 106. This homework, guys, is really easy. I'm not wrong. Every once in a while I am, but not often. Guys in back, please. Micah. I said guys in back first, and then again, you're the one that still kept talking. Okay, Micah. I apologize for you not talking. Okay, Marissa just bought 100 acres. I want to grow apple, peach, and cherry trees. Color model to show how it could be distributed. Do they have to be equal? No. So, a little Miss Warhit, do rows of 10. Just divide them into 3. Don't try to do it evenly because you get nasty numbers. Okay? So, you get to choose. Do it easy for yourself. Number 2, I will add, though, they did make you do all 3. Don't forget to do a key. Okay? Put a key in there so we know how you've divided those up. Turn the page. So each page only has really one problem. This one is actually very similar to what we just did. Only 30% of one wall is left without any decor. So shade it in to represent the space that is left to decorate. Take your time, read it. But what did they say? 20% is without decor. So how many should I be shading in? Oh, 30. I couldn't read it because I covered it too much. 30, thank you. So how many of them should I be shading in? 30. Make sure you answer the rest of the questions based on that. I'll give you that hint. Okay? That's